Okay, so in this video we're going to be looking at inverse proportion. So hopefully you've watched the video on direct proportion, and I'm just going to go through an example of something that's got inverse proportion. So with inverse proportion, as one variable gets larger, the other one gets smaller. Now you might recognise that because that's what we talk about when we talk about negative correlation. Now this isn't correlation, but the similar principle applies. As one value gets bigger, so in this case the time that passes after perhaps buying a brand new car, or the age of the car, as the age of the car gets bigger, the value of the car drops down. Now this is a very simplistic model because in reality a car doesn't drop value in a linear way. Okay, sometimes it'll have a big drop and then it'll sort of tail off. Cars don't normally sort of end up being worth nothing either. You can always get a little bit of money for them on scrap, even if they're dead old. And sometimes you'll even get vintage cars where their value drops down and then it goes back up through the roof. So this is a very simplistic version. And we are assuming in this version that we do have a linear decline, so that they're going down by the same amount every time as this car gets older. So every year, for example, it loses the same amount of value. So this car started off, where it's sort of crammed in here, this car started off being worth £20,000. Okay, so at 0 years old, when it was brand new, it was £20,000 worth of car, and over the course of 25 years, it's unfortunately now become worth nothing. So in this example, so this is our sort of x and that's our y, we can see in this example that y is inversely proportional to x, because as x has increased, as the age has gotten bigger, the value of the car has gone down. So you'll notice that that word direct proportion isn't there, okay? Inversely proportional now, or inverse proportion, is what we see there. And in terms of this example, I've just written it out for you to see it in sort of the layman's terms. The value of the car is inversely proportional to its age. So as the age gets bigger, the value of the car gets lower. So how would we write this? So again, we would use our symbol. Okay, it looks a bit like an alpha, there we go. So that's to say that it is a proportion. But as it's inversely proportional, that means we're going to have a sort of fraction, because as this gets bigger, this gets smaller. And if we think about a fraction, if that was the number 2, that would give us a half. If I put 3 in there, that would be a third, and a third is smaller than a half. You know, if you had the choice between half a cake or a third of the cake, which one would be bigger? And then if I kept making that bigger, so if I put x equals 10, 1/10, okay, so as this gets bigger, think about what happens to y, it is getting smaller. So inversely proportional means that you are going to have a fraction, okay, in your initial description algebraically. How does that work when we want to find an actual equation? So we would change this symbol for the equals, as we know, and instead of the 1, we're going to have that constant of proportionality again. Okay, and then there's the value of x. Now I couldn't go any further with this question because I haven't been given a piece of information about x and y. Were this an exam question, I might say something along the lines of, when x is equal to 12, so that might be 12 years old, y is equal to, let's say, £15,000. Find the equation sort of between x and y. So you need to be told those things. You need to be told that y is inversely proportional to x. So in this example I've been told that. You need to be given a value of x, and you need to be given a value of y. Those are the 3 parts that you need for this formula. So I started off by talking or describing this relationship as an inversely proportional one. I've started to look at how I might write it as an equation, and now I'm going to substitute the values in. So y is 15,000, so I'm substituting that in there. I don't know what the constant of proportionality is, I need to find that out. So how much is it dropping by each year in this case? And then when x is 12, that's what I get there. So rearranging this, if I want to get the value of k on its own, I need to get rid of my divide by 12, and I'm going to balance that out by timesing by 12. So that constant of proportionality, okay, if I look at that, 15,000 times by 12 gives me 180,000. So clearly the car that I had here was something like a Lamborghini or a Ferrari, you know, something low-key. And similar to the last set of questions, you will need to rewrite this now. That isn't the end of the question, because I'm asking you to find the equation. This is just the constant of proportionality, so the equation is that y is 180,000 divided by x. That's the final part that we need to have. And then we can start to look at all different things. So if I wanted to know what is the value of the car after 3 years, okay, so that would mean that x is equal to 3, because x is our variable which tells us how old the car is. Then what I would do is rewrite my formula, so 180,000 over x, substituting in that x is equal to 3. So that means that after 3 years the car would be worth £60,000. Or I might decide that I want to know something different. When will the car be worth, let's say, £50,000? So we want to know how long is it will take for the car to be worth £50,000. And that's the same as thinking of the value of the car, which is our y variable, being equal to £50,000. So again, I would write my equation. Y is equal to 180,000 divided by x. This time though, my substitution is going to be this y. So 50,000 is equal to 180,000 divided by x. Now to rearrange this, it is really straightforward, but I'm just going to do it in 2 steps anyway, so that you can see it one step at a time. So I need to make x the subject of the formula, but it's currently at the bottom of a fraction. So I'm going to multiply both sides by x. So dividing by x, timesing by x, they cancel out, and here I will have £50,000. So 50,000 now times by x, so 50,000x is equal to 180,000. Okay, and then to make x the subject, I need to remove this 50,000. As it's timesing, I'll do the opposite. So I'm going to divide by 50,000. So x is 180,000 divided by 50,000. And again, just if you wanted to, if you have a look between sort of this line and this line, it does just look like we've swapped the x and the 50,000 round, but I've gone through to explain why that has happened. So the 180,000 divided by the 50,000 is going to give us an answer of 3.6. So it will take 3.6 years for the car to be worth £50,000 in this example. Now, it's not often that you'll get questions in context. Most of the time the question will just say find the value when y equals, or find the value when x equals, and you were just substituting them into the formula that you came up to start with. And that's that, inverse proportion done.